And that's when I said, your mama's so big she has her own gravitational pull and inertia. Ha!
Dude, that's so messed up.
Hey, I'm Mr. Gallant.
And I'm Coach Parrish.
And we're here at Green Acres Middle School where we're doing...
Unit COVID-19, Earth's place in the universe.
And so we've been talking about our observations so far. Where we left off in the previous unit was with our gravity model. And how do we explain that, Coach Parrish?
In our lesson 7 gravity model, we talked about how things with greater mass have a greater gravitational pull on them, or gravitational force. And we know that everything's gravitating around the sun, and we're in motion around the sun. Earth, Mars, Venus, Jupiter, Saturn, taking longer than others because of the mass is different for each of those. So the gravitational pull kind of gave us our inertia, which keeps us going around and around, but not into it exactly, but getting pretty close sometimes.
Eventually.
Yes, eventually.
And then from there, we kind of asked you the question, how does gravity affect things other than solids? We said that we know it affects the planets and stuff like that, but how does it really affect the water here on Earth? So I have some questions for you, Coach Parrish. First question is, does gravity affect water?
Yes.
Yeah. Does water flow off the Earth?
Float off the Earth? No.
No, it doesn't. It might evaporate, go up in the atmosphere, precipitation, the water cycle, but it really doesn't just float off the Earth. Which way does rain fall?
Down.
Okay, it all goes down, and
Or is that perspective?
ooh. But then you look at waterfalls, and waterfalls go down if you're really chasing waterfalls, but you should never go chasing waterfalls.
No.
Can water go up?
That's a good question.
Because we know we filled up a bathtub or a swimming pool. That's the water level going up. The water has to go down out of a hose or a faucet to fill it up. So we saw the water going down as the water level goes up. So I saw these weird videos on YouTube.
You and YouTube. Yeah.
I know. I saw these weird videos on YouTube, school approved, and it showed the water kind of going up and down. And I kind of want y'all to see these videos, and maybe we can kind of talk about them a little bit. Sound good?
Sounds good.
So let's watch them. Okay, so welcome back. Those are some really cool videos. We saw the water going up and down. I've seen that a lot at the beach.
Yep.
But Coach Parrish, I want you to think back those videos, and I want you to answer these questions. Now, the first one is, what about the weather in those videos?
It was nice, sunshine, and no rainstorms or nothing, no tsunamis.
Yeah, so it's really pretty weather.
Absolutely.
What about, do you think this has happened before? Do you think those people were used to this happening?
Well, deducting in the videos that in the second one, the bridge, the little pier was able to go up and down like it was built to move with the tide. And in the first video, I don't think the people dragged the boats in there. I'm sure they used water to get them in there. So I think yes.
So everything was designed for the water to go up and down. Okay. What could be causing this change?
That's a good question.
So in the last lesson, we talked about how gravity is kind of pulling, interacting between two objects.
Yeah.
So we saw the water being pulled away. So that kind of tells me that gravity is probably being involved here. So gravity from something.
Somehow, some way.
So if we've been talking about the two big objects that really affect a lot of gravity on Earth, we have the sun and the moon.
Yep.
So which one is it? Which one is causing the water level to go up and down, which is tides? Could it be the sun?
Could be.
Why would it be the sun?
Well, it's bigger and has more mass, so it has more gravitational force on us.
Okay, so it's bigger, it has more mass. Why could it be the moon?
Well, it kind of could be the moon because it has gravity. It's a third our size, so a third the gravity, but it's also a lot closer.
A lot closer. So could be the sun, could be the moon. Okay, how can we figure out the answer? Now, I can go and I can get on a computer and I can do a whole bunch of research.
Google it.
Ask Siri or ask Google, ask Alexa, I don't know. But I think that'll be a little bit boring for you just to watch me on the computer. So we do notice in the video that the water goes up and down in a pattern.
Yes.
What other patterns have we talked about in this lesson?
Moon phases.
Yeah.
That was a pattern.
And we were talking about that it might be the moon.
Yeah.
So could it be possible that the moon phases pattern might be connected with the sun's pattern? Or I mean the tide pattern.
Could be both of what you said.
So here I have the moon phases of April 2020. So these are the moon phases from last month.
Yep.
And if we kind of go over this, okay, I see that the full moon happened on the 8th of April, and it kind of probably started here, full, and kind of arched there.
Because it should happen about 7 days, because we do have our first quarter here on the 1st, and if you add 7, well, you get 8, right?
And we say about, we make sure to say about, so a certain student doesn't go, well, it's actually 29 days. We say about, it could be 28 days, could be 29 days, could be about 27.67 days. It kind of depends. But we do know that full moon happened on April 8th. The quarter moons, they're on the, kind of in the 1st, the 14th, the 30th, but I'm going to kind of focus on the 14th and 30th here.
Okay.
And then the new moon happens on the 23rd. Okay, so here's our next one. So here's our lunar phases. Now we're going into our tide. So this is our high tides and low tides map from Shelter Cove, California. So if we look at our frequency, which is the high point to the low point here, we notice that the highest tide challenges are on April 8th and April 23rd.
So high tides are on the biggest change. Between the highest are going to be on the 8th and the 23rd of April, which was, this day would have been our full moon right here, which we have the highest of 6.35 going into the 8th. So we have our highest areas here.
And then we see our lowest changes happening on the 14th and the 30th.
Which were the third and, which were the
First quarter moon.
First quarter and the third.
Yeah, so if we bring our information together, we have our lunar calendar, the full moon on the 8th, the quarter moons on the 14th and 30th, and the new moon on the 23rd. And what do we notice about our tide calendar?
Well, we noticed that the highest tide changes in the whole calendar were happening on the 8th and the 23rd. Now, by that we mean how the highest it goes to the lowest that it's going to go.
And then,
The lowest tide changes are going to happen on the 14th and the 30th, which means they're going to change, but they're not as drastic as they were here. Their amplitude is smaller. They don't go way up and down, but they do go up and down, just very minimal.
but our dates match up. The full moon and the new moon match up with our highest tide changes.
Yep.
And our quarter moons match up with the lowest tide changes.
Yes.
So we're kind of showing here that the moon's connected. The moon's connected with the tides.
Gotta be something.
But what's also interesting, if the moon is connected, we should see something else. Because what I see here is, here's the full moon. It has the highest tide changes here at the full moon when the moon is on the other side of Earth. And on the new moon, when the moon is in between the sun and the earth, we still have big changes, but they're not as big as the full moon. And when I look here at the third quarter moon and the first quarter moon, they're the smallest, and they're almost kind of the same. But what confuses me is right here, these should be the same if it was only the moon. But since they're not the same, that tells me it's not just the moon.
So something else is gonna be working with it.
And the only thing with the big enough gravitational pull on us would be
The sun.
the sun. So it's not just the moon. It's not just the sun.
It's a duo.
So that gets us into our model. And so what we get into is with a new moon and a full moon. So we have our sun, we have the earth, and we have our new moon, which is when the moon is in between. And we have our full moon, which was the earth, moon's on the other side. We end up getting our biggest tide difference, okay? And that's because we have our solar pull pulling, and we have our lunar pull pulling. And when the moon and the sun are lined up, they're kind of working together. But when the moon's on the other side, they're kind of fighting each other like it's tug of war, and they're going back and forth a lot harder. But when we start looking at the quarter moons is when the moon's at a 90-degree angle.
Yes.
So it's not really fighting. It's not really helping. It's just there.
Kind of like they're working solo now.
They're working solo.
Yeah.
So the sun's pulling from its solar pull, the moon's pulling from its its own lunar pull, and it kind of almost evens things out because they're all working on their own. Now, what kind of tides are these called, Coach Parrish?
These tides that occur during new and full moons are called spring tides.
Like a bouncing spring.
Yes. It's actually come from the German word springen, which is to jump. Fact right there. Right?
German and science today.
Haha. Yes. And then the quarter moon areas where we really don't have that much of a drastic change, these are called neap tides. And those happen the opposite of these when the moon's at the 90-degree angle.
Okay. So we kind of figured out that it's not just the moon, it's not just the sun, it's kind of both of them together that give us our spring times and our neap times. So let's go back and look back at our lesson question. And our lesson question here is, how does gravity affect things other than solids? And what we figured out is, first of all, the gravitational pull from the moon and the sun affect large bodies of water on Earth, like our oceans. We also see when the gravity of the sun and the moon are combined, the tide is higher. So that's when we get our spring tides, when they're kind of playing tug of war, working together. And then what else did we notice?
We noticed that the gravity of the sun and the moon are counteracting each other. The tides are lower.
When they're at the 90-degree angle.
Correct. They're not working in tandem.
Okay.
We know that thermal evidence, in certain places, the water level changes drastically in a repeating pattern.
Which is our tides.
Yep. And we also know that the calendar of the tide levels and the moon phases had a correlation, and they kind of lined up.
Okay. So, really changing our initial model. I mean, where we first showed that the Earth's in the middle and everything moves around, and we've really changed from that. We've learned a lot from that. We've really fixed our model. But I still think we're focusing on just the Earth, the moon, and the sun. Is that all there is?
No, there's a lot more than that.
There's a lot more than that. So, are they all the same?
Are they?
Are they all different? Is there something hiding that we don't know about?
Or can we see everything?
Ooh. You know what? I think we need to talk about that in lesson 9.
And we will see you then.